The Mars Climate Orbiter mission of 1999 was a groundbreaking project meant to unlock the secrets of the red planet's atmosphere. However, what should have been a historic success turned into a catastrophic failure that cost NASA more than $120 million. The embarrassing measurement mix-up was a colossal error that could only happen in space, where kilometers and miles can get as mixed up as an astronaut's laundry on laundry day, leading to chaos and utter disappointment. It's a tale of human error, engineering oversight, the weird history of our measurement systems, and the high stakes of space exploration. Join us in today's video as we dive into the details of how this tiny mistake led to one of NASA's biggest and most costly disasters in history. In the late 90s, NASA suffered a number of budget cuts. In order to impress, they tried achieving a lot of incredible feats with a lot less money. Most of their attention was fixed on Mars, and they sought to uncover the mysteries of the not-so-far-away red planet. In a bid to uncover these mysteries, NASA launched the Mars Climate Orbiter, or MCO, in 1998. It was part of a larger program called the Mars Surveyor Program, which aimed to explore Mars and study its climate, geology, and potential for past and/or present life. The Mars Climate Orbiter in particular was designed to study the Martian atmosphere, its temperature, pressure, and composition, as well as map the planet's surface. The MCO mission was a joint project between NASA and the Lockheed Martin Corporation. NASA's Jet Propulsion Laboratory was in charge of guiding and navigating the spacecraft, while Lockheed Martin was tasked with building and designing it. The MCO was launched from Cape Canaveral, Florida on December 11, 1998, and it traveled for more than 9 months before it got to Mars. Have you ever tried downloading a game or app that everyone can't shut up about, and just when it reaches 99%, it suddenly closes and does nothing? Imagine you paid $30 for that game and it didn't even work. Well, the same kind of thing happened with the Mars Climate Orbiter. Just when the teams from NASA and Lockheed Martin were expected to celebrate the completion of their mission, the MCO entered the Martian atmosphere and was never heard from again. Just like that, NASA literally flung $125 million and months of work into Mars and received nothing in return. They could have accomplished the exact same result with almost no effort by taking a duffel bag full of $125 million and lighting it on fire. So, what actually happened to the video game? Minecraft. Spacecraft. During the MCO's journey to Mars, NASA had to perform what is called small thruster or correction burns. These correction burns were done to afford the Mars Climate Orbiter a high degree of accuracy for entry into Mars's atmosphere. Yep, real accurate, guys. Great job. Over the course of 9 months, NASA performed 4 of these correction burns as ground control tried to align the MCO with a predetermined target. There was one small problem though. When Lockheed Martin was given the contract to design and build the spacecraft, the company was expected to use the metric system. But the company instinctively did the opposite and used the imperial system, spelling the mission's doom. The age-old measurement dilemma. To fully understand it, let's do a quick dive into history. In the 1700s, there weren't really any standardized measurements, and people just about measured things however they saw fit. That meant using anything from some random guy's foot to the length of certain seeds and so many other ridiculous things. That is, until the French decided to invent the metric system. The metric system, also known as the International System of Units, or SI, was developed in the late 18th century in France, during the French Revolution. The system was designed to be a universal and decimal-based system of measurement that was easy to understand and use. Its development was led by a group of scientists and mathematicians, including Antoine Lavoisier, who is often called the father of modern chemistry. They sought to create a system of measurement that was based on fundamental and universal constants of nature, such as the speed of light and the mass of a specific type of atom. Crazy, right? They were really smart, even in the 1700s. The metric system is based on the meter, which was initially defined as 1/10,000,000th of the distance between the North Pole and the equator. Today, it is defined as the distance that light travels in a vacuum in 1,299,792,458ths of a second. That's true. Other units are derived from the meter, such as the kilogram, a specific mass actually represented by a cylinder of platinum-iridium alloy kept at the International Bureau of Weights and Measures, and the second, based on the length of a day. The metric system has since been adopted as the official system of measurement by most countries in the world, and it is widely used in science, engineering, and everyday life. Its simplicity and consistency quickly made it a popular choice for standardization across various fields. The metric system seemed the most reasonable, and France did its part in making sure that as many people in the world as possible used it. Why wouldn't they? They spent around 7 years coming up with it. Strangely, the United States didn't get the memo, and you won't believe why. It was primarily because of pirates. Yes, it's a bizarre story of tropical storms, English pirates, dead French ambassadors, and misidentified American statesmen. In short, the Frenchmen's standardized model of a kilogram, which was meant as a gift for Thomas Jefferson, never arrived in Jefferson's hands, and the US never adopted the metric system. Instead, the US decided to stick to the old ways of using people's arms and feet to measure things. Even more strange is that later on, when the US authorities tried to pass bills to adopt the metric system, the public rose up in protest against it. Yep, everyday American folks were marching in the streets, holding up signs saying things like, "Guard the gallon," "Preserve the pound," and our favorite, "Don't bounce the ounce." Even now, there are still anti-metric groups in England and the United States that protest against the use of the metric system, like the Active Resistance to Metrication, or ARM, group in England. Can you believe that? Shout out to any ARM members watching this video. Now you know why America doesn't exactly use the metric system, except for in the engineering and space sectors, where it has been embraced for decades due to its global status. Hence our increased confusion as to how this Mars climate orbiter accident even happened. We hope you enjoyed that brief history of the metric system, but now we must return to the MCO. So, you probably understand the whole unit conversion issue that happened, but maybe you're wondering, how bad can that actually be? Well, imagine two groups of engineers, one using the metric system and the other using the imperial one. It's like two people trying to dance the tango, with one doing a waltz and the other doing the cha-cha. We would not like to get our toes anywhere near that dance floor. That's not exactly what happened though. This is. During the spacecraft's journey to Mars, NASA's navigation team had been expecting to receive data in Newton seconds, the metric standard, but unknowingly, the team instead was receiving data in the imperial unit of pound seconds. The spacecraft was actually programmed to use the metric system to calculate its altitude and position as it approached Mars. But, unfortunately, the ground team software was reading the data being sent to and from the orbiter using the imperial system. This caused the spacecraft's calculations to be off by a factor of 4.45, including the aforementioned correction burns. As a result, the Mars Climate Orbiter was thrown off course and entered the Martian atmosphere too low and at too high of a velocity, causing it to burn up and disintegrate into the planet's atmosphere. This catastrophic error caused NASA to lose the spacecraft and all its valuable scientific data. The error was then traced back to a failure of communication and standardization between the NASA and Lockheed Martin teams, highlighting the importance of clear communication and standardized procedures in space missions. It's interesting that this is only one of many issues that have occurred because of problems with units, and some countries refusing to accept metrication. Another famous incident is one where an Air Canada Boeing 767, the first metric plane in Canada, ran out of fuel mid-flight because the ground team had filled the tank based on pounds per liter instead of kilograms per liter. Fortunately, that plane didn't crash, but only thanks to some expert gliding. The incident with the MCO taught scientists and engineers at NASA and Lockheed Martin a valuable lesson, one that we hope will be passed down to the team of engineers and scientists that send the first humans to Mars. Imagine if there had been people on that orbiter. 5 years after the incident, NASA and Lockheed Martin used the lessons learned to successfully land the MCO's replacement, the Mars Reconnaissance Orbiter. All in all, the MCO disaster may not be attributed to one thing, but it definitely shows that even the best of us can make the silliest of mistakes. So, next time you add a tablespoon instead of a teaspoon of salt to your recipe, don't be too hard on yourself. At least, your mistake didn't cost $125 million. What do you think of the Mars Climate Orbiter incident? An honest mistake or an unforgivable one? Let us know in the comments.